Okay, I wanted to do a review for the test, and I thought I would make a video for you guys. I've already sent you guys a list of definitions and concepts that you need to be aware of, things like what's an insulator, what's a conductor. And so in this video, I'm going to focus more on things you need to work problems, and I'll go over some of the problems that'll be representative of what you need to be able to do. Obviously, the first thing that we covered was Coulomb's law. And of course, you are going to be expected to be able to do problems involving Coulomb's law. And so I've written it here. This is Coulomb's law right here. So if I've got two charges, Q1, Q2, and the units of charge is, of course, coulombs. I've got Q1 and Q2. They're separated by some distance r. Here I've got R12 is the distance from charge 1 to charge 2. Coulomb's law tells us that the force between the two charges will have a magnitude given by the K value, which is 9.0 times 10 to the ninth Newton meter squared per coulomb squared, times the two charges multiplied together divided by the square of the distance between them. And so that's the magnitude of the force. What's the direction of the force? It depends on whether the charge is positive or negative. And so we know if the two charges have the same kind of charge, they're both positive, they're both negative, the force is going to be repulsive. If the two charges are opposite, then the force is going to be attractive. So if I give you two charges and I ask you to calculate the force between them, you should be able to do that by looking at what the signs of the charges are and figuring out which way the forces are, and also simply plugging in the numbers into this formula here and get the magnitude. Let's look at an application. Okay, I've drawn a setup here of a typical problem where you have a bunch of point charges. Here we've got 4 different point charges. Each charge is at the corner of a rectangle, and we want to find what's the force on one of the charges. So for example, we want to find what is the force acting on Q4 right here. So what are we going to do? We're going to use a superposition principle that tells us that the total force is the vector sum of all the individual forces. And it's very important, vector sum, not just sum, vector sum. So I want to figure out what the force is on that charge Q4 from the others. How do I do that? Let's assume they're all positive, and so they're all going to be repulsive. And so we know that the force from 2 on 4 is going to point down like that. And we know that the force on 3 on 4 is going to point to the right like that. How do we know that? Because if all the charges are positive, there's going to be repulsion. So the force is on the line from 2 to 4, so we know they're going to repel, so that force is going to be downward. This force is going to be to the right. And then what about Q1? Which way is the force from that one going to be? Well, obviously it's going to be diagonally. And so we could write out F3,4, this one is F1,4, and this one would be F2,4. And I've got 3 forces that are vectors. And I found the directions. I used whether the charges are attractive or repulsive to determine what the direction of the forces are, and I found the directions. Now, in a problem, when you say find the directions, what you really mean is find the angles. Obviously, this force F3,4 is to the right. This force F2,4 is downward. What about F1,4, this diagonally downward one? Well, we can say that that force is on that line, and whatever angle this guy is, that is the angle that F1,4 will also make. We know that this distance is 3, this distance is 4, so we can use the arctangent to find that angle. So now I've got 3 vectors, F3,4, F1,4, and F2,4. What am I going to do with them? I've found their directions. A vector has a direction and a magnitude. So I'm going to find the magnitude using Coulomb's law. F is equal to K Q1 Q2 over R squared. It's that simple. K Q1 Q2 over R squared. And so that is how we apply Coulomb's law to these problems to get the magnitudes along with the directions. So now what do? We've got three different forces. We've got a force that's going to the right, we've got a force that's going down, and we've got a force that's going at some sort of angle theta. So I have three different forces here, F34, F14, and F24. I've got their magnitudes, which I've calculated with Coulomb's law. I've got their directions, which I have calculated, which I've determined from the picture and from the geometry. And so now, what do? I do vector addition. I've got to break all these guys into x components and y components and do vector addition. And you should know how to do vector addition by now, because we've done it lots and lots. But we have examples for you to look at where you can do this, but this is the approach. So again, when you're doing Coulomb's law with point charges, you use the geometry, you find the directions. That means find the angles. You use the formula to find the magnitudes. Once you've got the magnitudes and the directions of each of the force vectors, however many there are, you do vector addition. Those three things that you can do, if you do two of them, you're going to get partial credit. You know, if you do all three of them and you do them correctly, you're going to get full credit. So again, you got to think about the steps here. What are the steps of finding the force on one charge when you've got a bunch of other charges attracting and repelling it? These are the steps. Find the directions of all the force vectors, find the magnitudes of all the force vectors, and do vector addition. Now, rather than making one giant long video, I think I want to make, 5 or 6 little videos like this one and post them. So I'm going to let this be the video that talks about Coulomb's law, and we'll go on and I'm going to talk about electric fields next, which is the next topic you need to prepare for the test.